of two squares, and we don't have a rule for sum, only difference. Okay, if the polynomial is a binomial, something else we can check is to see if it's the sum or difference of two perfect cubes. Cubes are numbers that you can multiply by themselves to give you, 3 times by themselves. So like 1 is a perfect cube. What's another perfect cube? 8? 27? Let's see. And then the other one's 4 times 4 times 4, 64. 5 times 5 times 5 is 125. 216. So there's a few. Just so when you see those are, if I took the cubed root of those, it's 1, 2, 3, 4, 5, 6. So just maybe make them a little more apparent to you. Okay, so here's the way this works out. If you have two numbers that are perfect cubes, then they become a minus b. So you take the cubed root of each one of those. That's the first number squared. And then the sign is the exact opposite. So plus those two numbers, a times b, and then the last number squared. It works the same with a cubed plus b cubed. There is a sum of two cubes. There's not a sum of two squares. That will factor into a plus b.
Isn't that soap?
Soap. Ooh, tell me soap. I don't know soap.
Said so. It would be the first one is same, and then the next one is opposite. So the first one it would be positive since it's opposite of negative, and then AP is always positive for the last one.
Oh, I see what you're saying. So it's soap, y'all. This is going to smell really good when we're done with it. With all the soap. No. I like it. So, yeah. So, yes, it is. It is soap. So, it is same. So, a squared. Opposite. So, negative AB. And then always positive. I like it. Thank you, Mr. Ricker. All right. So, first thing we do is we look to see if it's in the correct order, which it is. X cubed is the highest exponent. It's first. Then we look for greatest common factor. Is there anything I can factor out? Is there any number or variable that will go into both of those?
No.
No. Then we look for difference of two squares. No, obviously not. So it must be then a difference of two cubes. So that would be, what's the cubed root of x cubed? X. And the cubed root of 27? 3. So you just leave that minus. And then it's the same sign. So x squared. Opposite sign. So plus, and then you multiply these two numbers together, the 3 and the x. And then always positive. Negative 3 times negative 3 is always positive. And when it's a difference of two squares, that second one will never break down anymore. So you don't have to worry about trying to no-fuss it or seeing if there are any numbers to multiply to give you 9, but add to give you 3, because it won't. All right, awesome. Jenna, what can I factor out of this one? 2x. Justin leaving me with? After I divide by 2x?
X cubed plus 4. Plus 8.
Very good. Yep. And then x cubed plus 8, Tyler.
Factor out the cube.
So it becomes.
That's where I always get.
Oh, okay. Just look at this one. You just take the cubed root of each one of them. So what's cubed root of x cubed?
Would be x.
Yes. And then cubed root of 8?
2.
2. So it's that same sign, plus 2. Then you take the first one, you square it. That's the opposite. So minus, multiply those two together, 2x. And then that last number squared, and it's always positive. That's all we can do with it. All right. Of course, I'm going to let y'all try this one. And then you divide 192 divided by -3. You may have to decide and work that out. That's okay. That looks right. If it's not, it's just a sign or something. But that looks right. No, you're going to tell you. Yeah, looks right. Then it's opposite, so you put minus. You multiply those two together, so 4x. And then that gets squared, so it's always positive. Yep. Okay. So factor out a -3x. So it leaves us with x cubed. Now there's nothing wrong if you can't take 192 divided by 3 in your head. I probably wouldn't. Let's see. 6, 18. 3 goes in 12, 4. So that's 64. And it's positive 64 because you factored out a negative, because that first number was negative. Way with me so far? Okay, then this is a sum of two cubes. So -3x and x plus 4. First number squared, opposite 4x, always positive 16. If the polynomial is a trinomial, check to see if it will factor as two different binomials. That's the no fuss stuff. if you can factor out the number in front,